Morning. Switching gears a little bit, I'm not gonna talk about AI. Hope it's as interesting as we can make it. So I'm gonna talk a little bit about how at BASF we have been tackling, let's say, our data challenges in the past, let's say, 10 years, starting at the era of next generation sequencing. All of those scientists, researchers, sequencing data, getting those data in, not only sequences, but phenotypic data, all of those things. And how are we in BASF now working with that data? How are we organizing it? How are we essentially managing it? A little bit of an introduction. So BASF has several divisions. I'm in the agricultural solutions division, and it's more on the top left side. I'm working in field crop seeds in the research and development department. The end product of what we are doing essentially is seeds for the professional farmer. So we're talking about canola seeds, soybean seeds that we sell worldwide to our customers. In this R&D, I'm in a specific group which is called Seeds Technology and Analytics, and we focus essentially on developing all types of technological solutions. Most of that is indeed in the digital space. But we also talk about modeling, about high throughput genotyping, digital phenotyping, which is essentially building machines to take pictures automatically of plants in different ways. And more also important is if we create and we generate and we get a lot of data in, we need a consistent and good data strategy and governance, which is essentially one of the major challenges that we had in the past 10 years. A little bit about me. I put a big picture of myself, but I should not have done that. I'm here. So I have a bachelor's in computer science. I started my career as a regular systems engineer, Linux systems engineer in College University of Ghent. Moved in 2009 to Bayer. And then in 2018, Bayer decided to buy Monsanto. And we were essentially divested into BASF, where we are now continuing those activities, those crop protection activities. I have moved a little bit. When I went into Bayer, essentially I started working on high performance computing, which is something that I'm still responsible for today. But now I'm leading a little bit larger team, a group of people, not only covering high performance computing, but also the infrastructure like Kubernetes, application hosting, all types of databases, you name it, we have it, SQL, NoSQL databases, and so on. And this is the timeline I'm going to take you on a little bit. So we're going to start all the way back in 2011, when we started with our first high-performance compute clusters. And we'll see every year that we kind of have a slide talking about the challenge that we meet and what we have done in that year to really tackle those large data challenges. 2011. These are our two incredible, nice innovation centers, as I can say. So on the top, you see our innovation center in RTP, so North Carolina in the US. It has the BASF logo, but in 2011, that was a Bayer logo. And on the bottom, we have our innovation center in Ghent, in Belgium. And essentially, I was working for Bayer for about 2 years at that time. At that time, when I went to conferences, the only thing you saw when you go to biotech conferences, life science conferences, was this graph with NGS, and the graph was going like in your perspective like this. Be afraid of NGS, be afraid of next generation sequencing. It's going to explode data. We also were starting to work on phenotyping solutions, again, building these systems where essentially we were taking pictures of plants 3 pictures a day in different formats and so on. Trying to get information out of that. And of course, it's not only the sequencers that we had in-house, but we had a lot of, let's say, scientists and divisions that were also essentially outsourcing their sequencing efforts. So it was also a continuous stream of receiving disks and putting those disks on our high-performance compute environments. This is something we started in 2011. In 2009, when I arrived, all bioinformaticians were working on one server. That was the single system. It was kind of a problematic situation if that system had to be patched and so on, because then we had essentially 10 people doing nothing. Either were doing Excel and these kind of things. So essentially, we had to build high-performance compute clusters in those two innovation centers, and these are essentially the capacities that we looked at over the years, which is compared to certain institutions not that big. But the thing is that we did have a lot of variety of data, and that doesn't take away the challenge of having to manage all those types of data for your business. Also, because in the end you have a commercial product, you also have all of the let's say audit kind of things and litigation kind of things. You have to make sure that the data is managed in a very structured manner. And also at that time, we started with building really a digital platform. We started having different development teams building solutions, not only taking data in, but also analyzing data and so on. 2012, we got really a lot of questions. And on the left side, this is supposed to be me in a much nicer version. The type of questions that we had from a data science perspective is always the same kind of thing. And one of the very specific questions I once got from a data scientist, and in 2012, I think it was still a bioinformatician, that I don't think data scientist really existed as a term that time. He just asked me, hey, look, I'm working on this file on the GPFS file system. How do I know this file is the same file as yesterday? And this is the thing, we had a quite open environment. We didn't have a very large department. The structure was quite open, I'm not going to say read-write for everyone, but it was very shared. It was also an R&D mindset. So the risk of indeed people making a mistake or impacting other people's data was essentially there. The other question that you can see is, people are putting data in, they're putting it in on locations. Where did my colleague put that? Colleague is on holiday, is getting ill. All of these things were really coming from, let's say, the data science part, and we didn't really have a real conclusive answer because you were just seeing as an IT person this big file system. That was the thing that you were seeing, and we had two of them. On the other hand, we had some struggles too. One of the things that we didn't like as an IT department is that, they took this, we have those sequence sets, it arrived here, and I'm like, yeah, but I want to analyze it myself, so I'm going to copy it, and I'm going to copy it in my own workspace. And before we knew it, we had 10 copies, I'm just exaggerating here, we had several copies of the same data sets lying around in this, on this very expensive file system. The other question is, what do we need to back up? Is this temporary data? Is this really business critical? Can we throw it away? Those are kind of really the typical, not only in 2012, by the way, it's still the questions today. Directory structures, insane directory structures. I'm just, again, putting a number here, but you can imagine what they create. And one of the cool things they started doing is they started inventing naming conventions, to say, okay, this is the species, this is the date we arrived, and before you know it, you had file names longer than whatever, and then it's like, yeah, but I cannot say put that file on the file system anymore. So we really had a couple of quite impressive challenges to answer, and then even the last questions, how we're going to save all of the data 10 years. Again, you have to think litigation, audit possibilities, and so on. You have to make sure that you keep the data efficiently stored, and rather not on that very expensive high-performance compute GPFS system, rather somewhere else where it's cheap and where you can keep it for a long time. The last question is was not at that time so specific, but now with cloud capabilities, moving data between data centers, between regions, on-premise to off-premise, that is becoming also more and more kind of let's say a challenge. We started thinking. 2014, essentially, data governance. Multiple people came and they said, look, we have to have better data management, especially about files. The thing is that if you have a table, you can put it in a database, and these kind of things are kind of easy as an IT guy to translate. But if you're looking at directory structures and files, that remains, and that is always a challenge. You all know this is fair. All your data need to be findable, accessible, reusable. Essentially, the data governance colleague said, hey, look, you have to build a system, or we have to build a kind of system we really have a future, we have a kind of a sustainable situation for managing all of these files. We also added some other requirements. I don't like file systems. They're very error prone, they're very problematic. The rights access management is always a struggle. So essentially for really putting and for really safeguarding that data, we didn't really want it to have a file system as a kind of backend system. If we built a system that we really wanted to offload the system, because that's essentially the idea behind it, we wanted to offload the data from the high performance compute system to a system outside. And there the data would be safe, it would be backup, and you could keep it for a long time. So data there should be immutable. The moment that you put a file there, you don't allow it to change anymore. We want to make sure that we could save, and this is not the total amount, but we could, let's say, save or move data away in blocks of a maximum file should be supported as 5 terabyte, which is conveniently the same maximum amount as in S3 as maximum file size. But also we would like to essentially save away blocks of data up to 200,000 files. 200,000 files is in certain cases not enough. We have seen analysis that generate up to 1 million files, which is kind of painful if you have to build a system that catches all those files and have to put it away. There are a couple of other things. One of the very important thing is that we wanted to really step away from the fact that you had to have a kind of directory structure with naming conventions and so on. We wanted to really have a kind of metadata system that was key value pair inspired. At that time also we were working on ontologies, and we really had the requirement, hey look, we want to make sure that we can use our taxonomy ontology to really have let's say structured metadata in this system. CLI, again, APIs, you had to make sure that that system was capable of talking to other systems, or better, the other systems were capable of talking to this system, but also the data scientist himself had to have an easy way of access, and then we had data scientists that said, no, give me a CLI or an API and I will just talk the system myself. A couple of other things, I will discuss those when we look at it, but essentially we started building, this is kind of an overview of what it looks like. It's essentially we build an application that we call data integration services. This application that we have in-house, let's say, developed, essentially is essentially a backend that is capable of taking files and putting it into object storage with then adding metadata on top of it. We don't take individual files, we essentially have collections of files, and we created this kind of logic where we said, look, we have a resource. That's why you see resource registry. And a resource can essentially have one file, or it can have even an entire directory structure up to 200,000 files with the maximum file size of 5 terabyte. In the front end, you have the very simple resource registry. This is the simplest of interfaces. There's a small screenshot in the next slide, but the most important thing is the bottom one, some application. There, essentially, what we did is when we started building and extending the platform of our digital tools, we essentially said from a data governance perspective, if you're managing files, you're using this system. And this allowed essentially to have one backend for all of, let's say, file management. We didn't have application development teams coming to us and say, hey, look, we need some kind of NFS share or whatever, or we're going to save files in blob storage in Oracle database and these kind of things. We completely moved away from that because we essentially put everything in object storage systems. Yeah, and this is the new logo that we made for today's session. So, the initial setup was quite straightforward. So I already discussed the resource concept. Essentially, it's like you have to look at it like as a virtual thing where you have one file or multiple files, and it's on the resource level that you add the metadata. So if you have sequence data, you say, okay, it's this species, it was sequenced by this machine, by this provider, and so on. We had a life cycle, meaning that the moment that you have something uploaded, either there was a draft status where you can still upload new objects to a certain resource or remove it. But the moment that you said, okay, this is live, this is available, essentially the resource is static. Even in draft status, all the objects that we saved, because they are sitting in object stores, they remained immutable. So if the moment that you upload an object, it remains there, you cannot even change it anymore. But you could essentially change a resource when it was in draft status. The moment it became available again, you could delete it from draft, and then the moment it became available, it was available for your use cases. And after a certain retention period, the objects would be deleted, but the metadata will always stay. That was kind of the idea. The initial setup, we worked with DDN. We put in 2 web object scaler systems in Ghent, and essentially they were synchronizing to each other to make sure that everything was safe. This is a little bit, the front end is, like I said, it's the simplest of interfaces. On the left side, you have all the labels, you have the state, you have the owner, and then you have the sizes, and when you have to create it. Essentially, what you see is people in our team, we would build much more advanced applications really for sequence genome management and these kind of things that had a lot more specific interfaces for managing the type of data. Once you build a system, you want it to be adopted. And everybody knows the feeling when they're behind this, right? I mean, this is a picture I found in our image catalog. I mean, it takes time for an organization to shift and to move, and it took quite a while. It took easily 1 or 2 years to get it developed and then to get it adopted. It took quite a while to really get it adopted in our organization. Also, there was some confusion sometimes. Okay, when do we use it? When do we not use it? And we had to, again, with data governance people and strategic management, we had to really say, okay, we're going to build this kind of waterfall. We already had set up the concept of have the specific data repositories like sequence databases and so on that that are managed by specific applications. Then we had essentially then we have essentially the data analysis gateway application, which is an internal application for really managing the process of a data analysis on a high performance compute, meaning a scientist starts an analysis, it creates this kind of really funny structure on the GPFS file system. And essentially the moment you add something to it, you can click a button and it puts everything in the object store. So it's kind of immediately secured, so to speak. And the default fallback is like this application I just showed you. It's like, I don't know really what to do. Well, there it is. Please don't use it as a SharePoint, because that was something that we saw also. We didn't want to create a new SharePoint. It became popular. So in 2018, we had to extend it. So we bought another object storage system from DDN. We put it in RTP. Also there we saw a large data volume increase, and we wanted to make sure that they also adopted it. And moving data from essentially RTP all the way up to Ghent was also kind of painful on the network. So that's why we said, okay, we want to have a local system so we can do really also local uploads into that system. We had a small crash in 2019. As I said, at a certain point, we became BASF. And the thing is that you have to integrate all of your systems into that new network. That caused a little bit of problems. So DDN really, you don't do that every time. You don't do that every day to change an entire data center, moving it into a new network. So we prepared that integration with our object storage systems also with DDN. That went fine, but in the back end something really went wrong. The thing is that DDN support was absolutely critical in making sure that whatever was happening was secure, because we lost a couple of objects, but we lost a lot of objects, but in the end we made sure that DDN made sure that we could recover most of the data. That did learn us something. So what we said, okay, and it's not only that, it's also, cloud was really becoming a kind of active thing. So we said, okay, we have to kind of start preparing that. So combining the learned lessons from that trouble in paradise on the previous slide, we said, okay, we're going to start synchronizing these systems to the cloud, also these data to the cloud also. We started doing that in RTP, so we had 2 zones in RTP from AWS, essentially S3 buckets, where we essentially we programmed the system to start really synchronizing itself. At that time, and this is something what you don't see, is this used to be one cluster with 2 systems. We split up that cluster and the synchronization was done by our software stack. So that if something would happen on the original, on the infrastructure on one end, essentially, it would not impact the other system. Also then in Ghent, we started using AWS we set up AWS S3 buckets, started synchronizing also over there. And then in 2023, we're also adopting now Azure Blob Storage to essentially send data to. Long story, quite short at this point. So right now we still have an on-site capacity of about 5.7 petabytes. It's again, compared to larger institutes, this is probably not a big number. What I think is quite interesting, especially because right now we're also in this cloud-native transformation. We're really moving applications to the cloud, but we don't have to worry about all of that file-based data because it's already sitting in the cloud. We already moved everything. We already copied and synchronizing to S3 in AWS. So we sync between those 7 storage facilities. We have adopted 2 cloud providers. And in the system right now, we have about 12 million files in those 200,000 plus resources. And I hope that gave you quite an insight of what we did. Thank you.
Thank you very much. So you've got this big framework for managing lots of data and the rest of it. As time's gone by, you've ended up with it in different locations, different clouds, but of course, each type of data has got different requirements, regulatory, archive, and that sort of thing. Do you actually kind of build that into the way the system works? Do you tell it what sort of data has to be there and which location, therefore, it's managed that way?
Yeah, so what you essentially saw was the core of the data moving thing, right? So it has essentially the basic mechanisms of storing it, synchronizing it between locations, even materializing it on certain file systems. If we say, okay, this data has to be in RTP and on GPFS, the system can do that. It materializes it, just puts it there. But the steering, depending on the data type, essentially. So we have essentially data repository applications. So sequence data has a very specific front end, especially sequence data is quite extensive because that's what we do, genome sequencing and genome analysis of that information and then data. So that's a very specific front end. And essentially we add functionality on top of that front end where where data governance and strategic is saying, okay, with this data you have to do this and this and this. And so the requirements are essentially built in on top of that in the other applications.
So you take care of it so the research teams don't have to in that sense?
Yes.
Yeah, okay. Okay, good. Any other questions for Filip before we move on to bring everyone up for a panel? Okay. Okay.
Could you just
to repeat it? What's the most common question you have from your internal users when you're planning for a new system?
Could you elaborate on what you mean with system? Exactly?
So you're building a data storage solution, even building your own thing on top of existing platforms.
Yeah.
So this is user driven or user requirement driven. So what is the core question that users say, this is what we want you to solve for us in the future?
It depends a little bit on the user. Most of the time they want it to be fast. They want it to be perform. So essentially, if I look at it from a data analysis platform perspective, really from high performance compute perspective, it's all in the performance. It's really, I want to be able to copy the data there fast. I need to download the data fast. Do you have a hard disk? I want it to be available on there. It's even from a service perspective. I mean, let's say the speed is kind of the most critical thing. If you however switch to the business side of things, for instance, data strategy, data governance, they want to know which data we have. And then it's really about transparency and building transparency into our different software layers to make sure, okay, can everybody find the data that we have, which is by far the biggest struggle that we have. To really make sure, I mean, we have lots of applications, lots of APIs, and everything is working that way, but it doesn't really give you a good view of what data is all available and so on. And I think, for instance, people are linking into the AI topic, are looking at, okay, we have tons of data. I mean, how can we use AI, or how can we really employ AI to make sense of that, or I mean, to do science on that and these kind of things. So that's.
Okay, thank you very much.
Yeah.
So just a short question as well. So you introduced very well the fact that you need to have object because you want to have immutable data. So at the end, you have like a 100% object storage system, or do you still have some kind of file system on the side?
Absolutely. Yeah. So the object storage system is it has three main functions. It's an archive for essentially all of the important data we have to keep along. It's integrated backup, of course, because you have a backup of the data that is sitting on your high-performance compute clusters. But it's also an interface for other applications to get to the same kind of data. But the real analysis really still happens on regular file systems, regular high-performance compute systems. So that doesn't change really.
So you have this nice metadata registry with maybe an ontology on top of it or inside of it. How open are you with that registry inside of BASF or your own department? Is it possible for others to think, oh, I would be interested in some kind of data set? Does it already exist, and can they look that up? Because that's a problem here, for instance, where people generate data and the group next door doesn't even know what they're doing. So having kind of a good metadata catalog that's available to essentially the entire company would be presumably really valuable.
Yeah. That's not an easy question. That's a very good question, but it's not an easy question because you have the different top layer applications. For instance, sequence repository application is really focusing on managing the sequence, all of the sequences that we have, and because of safety and IT security and those things, you have to essentially make sure that everything, the application is secure. You cannot just go into it. However, if you're from BASF and you ask access, you will just get access. It's not that we're going to kind of squeeze or we're going to say, oh, no, you're not from this department. No, most of the time when they want access to the application, they get access to the application because we are one company. So it's so that's not really, I don't see any limitations there. The challenge, and this is what makes the answer a little bit difficult, is what is a data scientist doing himself with resource registry, for instance. That was one of the discussions because they can upload whatever they want in that application and they can keep it private. And there was a kind of discussion around that. I mean, should we allow that and so on? We know who won because essentially now we have never removed the private functionality. So they can just upload stuff and keep the resources private for themselves.
Okay. Well, thank you very much, Filip.